Hi, this is lecture 2.2 of the Sage base course, Monte Carlo Methods. Let's look at example 1. We were just looking at the definition and notation of functions or maps. In example 1, we're going to see how maps and functions are encoded as sets of ordered pairs or as procedures. So first we will look at encoding functions as sets of ordered pairs. In Sage, we can encode a map as follows. It's the following set of ordered pairs. So here we have find father's map. It's a variable. Here is an equal to sign. So whatever on the right is going to be assigned to find father's map, the variable. And what's on the right is this entire expression. And we will come to what this expression is in a minute. And finally, after we've done the assignment, we are asking Sage to disclose this variable that we just assigned. So if I hit the evaluate button, I get that find father's map has been assigned this particular set of ordered pairs. There's Kathy, and Kathy's image is Jonathan. Here's Anu. Anu's image is Raz, and Jenny's image is Jonathan, and Ashu's image is Raz. You see how there is a colon separating each ordered pair, and there is a comma delimiting these ordered pairs. So given a key, in this case the child or daughter, we can use the map to find the father. So here is the next statement. We are asking Sage to print the string, the father of Anu is, and after that string we want it to print the value associated with the key Anu. So we're essentially asking, what is find father's map of Anu? Then the output is the father of Anu is Raz. So find father's map of Anu evaluated to Raz. We could also encode our inverse map of the find father's map as find daughter's map. So we map from one father key, example Raz, to multiple values for daughters. So for Raz, we have to map the inverse image to Anu and Ashu. So here is our find daughter's map, which is our variable now, and here is the assignment operator. And the thing on the right here, enclosed by these curly braces, is what we're going to be assigning to find daughter's map. Once again, we assign Jonathan. We pair up Jonathan with his pre-image, which is Jenny and Kathy, and similarly we pair up Raz with his pre-image, Anu and Ashu. So right now, don't worry about the way we've done the printing below. Just check that the output makes sense to you. Okay, so this is actually a for statement. You'll learn about this soon. What we are doing is simply going through elements. So Raz has daughters Anu and Ashu, and Jonathan has daughters Jenny and Kathy. We can also use a map for a simple function. Y equals x squared plus 2, and the domain is -2, -1, 0, 1, 2, and the range is 2, 3, 4, 5, 6. By encoding this function as a set of ordered pairs, -2, 6, -1, 3, all the way to 2, 6. This is how we do this in Sage. We now assign to this variable the following collection of ordered pairs. Once again, each pair is separated. Each pair, say -2 and 6, is separated by a colon. and each pair again is separated by a comma. So if I evaluate this expression, I get that my function map has been assigned this collection of ordered pairs. Looking up the value or image of the keys in our domain works the same way. So here we go. When we ask what is my function map of the key -2, we get 6 because -2 has been associated with 6 as its value. Now, if we ask for something that we did not assign, so -20 is not one of these first elements before the colon, right? So if we ask what it is, it's going to give me an error. Okay. So it says that the key error -20. -20 is not in the list of keys. But it is clearly not a good way to try to specify a function mapping that can deal with lots of different x's, right? In fact, it would be impossible to try to specify a mapping like this if we want the domain of the function to have infinitely many elements. For example, if the domain is the set of all integers, like version 2 of f of x we saw earlier, or all rational numbers, or the segment of a real line, then we are going to run out of energy trying to encode all these ordered pairs to represent a function. Instead, this is the second way to encode a function. Okay, this is called a procedure. In Sage, we can just define our own function as a procedure that can evaluate our image value on the fly for any x we want. So that's why it's called a procedure. It just sort of does it. It does the procedure of finding the image on the fly. We'll be doing more on functions in later labs, so for the moment just think about how defining the function can be seen as a much more flexible way of specifying a mapping from the domain of the function to its range. Some basics about encoding a function as a procedure. The function named myfunc we want to define is preceded by the keyword def. Okay? So this is explanation of what's happening in the cell below here. Okay, so this is the keyword def right here. So keywords are specially reserved words in any language, like Sage has lots of keywords. The function named myfunc is succeeded by an input by any input arguments. So myfunc is here. This is the function we're going to define as a procedure, and any of the arguments, input arguments that go into this function are going to be enclosed by a pair of parentheses, and that input argument is going to follow the name of the function. After we have defined the function by its name myfunc followed by its input argument x, we end the line with a colon. So this is a very important syntax. So we put a colon before continuing to the next line. Now we are ready to write the body of the function, right? So in the body of the function, it is customary to leave 4 white spaces, right? So in the next line, we have 1, 2, 3, 4 white spaces. And after the 4 white spaces, we are going to have a triple quote. This is where we put the comments. So here is a single quote, another single quote, and a third single quote, right? So this is a triple quote, and here is the end of the triple quote. And inside the triple quotes, we put the so-called doc string or documentation string. Okay, so these are comments on what the function does. So this is to help the user of the function know what the function is supposed to be doing. So this is a function to return x squared plus 2. That's our doc string. So in the next line, we finally go here, and again we put 1, 2, 3, 4 white spaces, and then we write return. Return is another keyword. So the function, when called, will return this expression, x squared plus 2. So this is simply the actual procedure that the function is going to perform when we call it. Okay, and this is just part of the comment here. Okay, so this is confusing. You can just sort of move this here. Alright, so now let me hit the evaluate button. Now nothing has popped out as output. That's okay, the function has been defined. So now if I ask my func question mark, so I've just defined my func. Now if I ask my func followed by a question mark, then it gives me this. It tells me where the file is, and it tells me the type. The type is a function, and it gives me the definition. This is how you would call the function, and it gives me the doc string that we just put in, a function to return x squared plus 2, the stuff that we put in here. So this is how somebody can easily ask what my func does, by just asking my func question mark. Now let's use the function to calculate 0.1 squared plus 2. So our little x is now 0.1, so we actually pass in an argument into the function, and 0.1 squared is 0.01, and then we add 2 to it, so we get 2.01. There we go, we've just evaluated a function, our function myfunc, for the argument little x being 0.1. If you go back and create another cell here and ask what is my func of 23.55, then it gives me another answer, and you can change it to anything you want. Right? So now we have a procedure implementing this function that calculates the image of any value you like to put in here on the fly. Okay? So when you evaluate the cell below, Sage will now complain about an indentation error. Okay, so an indentation error. What is an indentation error? Indentation error is that there are not the same number of white spaces before each line begins. So if you look here, there's 1, 2, 3, 4, 5 white spaces. So in Sage or Python, the way we look at blocks of code, we indent blocks of code, is by putting the same number of white spaces before them. So it's 1, 2, 3, 4, and 1, 2, 3, 4. So now if I evaluate it, it's fine. It's not going to give me an indentation error. Okay, so I can go back and reevaluate this function and get the same answer, or change the value, and I'm still okay. The command to plot is actually pretty simple. So the 4 arguments to plot are the function to be plotted, the input argument, that is the varying along the x-axis, the lower bound and the upper bound of the input argument. So here is the function that I want to plot, okay, that we just defined as a procedure, and this is the input argument, and here is the lower bound and the upper bound of the values x will take. So if I hit evaluate, I'm going to get a very nice plot of the function myfunc, which is x squared plus 2.